we are going to be talking about sprite collisions and how we can deal with them, and there are many different ways, but we're going to mainly focus on the hardware way and the mixed mode way. And I'll try and explain how it works. I've got the map in the 64 guide up with it on already, so I can make sure I'm right. But it looks like I'll be right. So I've got that up. So let's get started. Right. So on the screen is episode 10, where we was messing around with sprites. You know, when we did when we messed around with sprites that one time. I think it was for Brendan. Yeah, I think it was for Brendan. I got to keep remembering it's F5 in this, not F6. And we had this. Yeah. So we had a very simple so we got a very simple sprite mover. So what we're going to do is we're going to add another sprite, because the whole point of sprite detection, there's two forms of the sprite detection. You've got sprite on sprite action and sprite on foreground action. Now, sprite on sprite action means that one sprite has collided or touched another one, and sprite on foreground is that you've got a sprite that's interacted with the foreground characters, not the background. They are called foreground characters. The background is the background. Text is the foreground, yeah? And so what we're going to do is we're going to do both types of collisions, and we're going to try and explain exactly how the collision system works, because it's really, really weird. If you don't know about it, it can throw you. It threw me when I did Neptune Lander, because that was sprite on foreground action. So the way the sprite collision system works, and I'll say generally is you have 8 sprites, yeah? 8 sprites. And the collision system has 2 dedicated registers for the collision system. One for when a sprite's collided with another sprite, and one for when the sprite's collided with the background. And the way it works is each bit of that register, or those registers, represents that sprite. So like when we turn off the sprite, we've got a yes. So like when we turn on the sprite, we have a bit for each sprite that we turn on. So we have to do an OR and stuff like that. It's the same with the collision detection system, the hardware collision system. One thing. Okay. One thing you've got to remember with the hardware collision system is once you've read the register, it resets. It resets to 0. It doesn't keep its state. Once it's read, it's reset. So you can't read it again. Yeah. So you've got to be careful. It's not like other. Yeah, we need Bren. Well, I did say I was going to do it, but anyway. So you've got to remember, once you read it, it resets. So you can't read it again. You can't go, I'll read the register. Sprite 1 has collided. Right, I'm going to read it again. What's it collided with? Because you'll just get 0, yeah? And same with the foreground, because that threw me on Neptune Lander. You probably remember the episode where it threw me, and I think that was one of the episodes where I had to put a cutscene in. because it really threw me. That when I read it again, it was clear. and the thing is, from what I understand, the collision only reactivates when you move a sprite. So if you move a sprite pixel, it then re-registers. But if you leave them, I think it's, if the two sprites, I'm not sure, but we will try it, yeah. So what we're going to do is we're going to create another sprite to mess around with. So let's get into the sprite designer. Let's add a new sprite. So insert after. Yeah, that's what I thought. It refreshes on the next raster, but you know, it, like I say, we'll find out because it threw me on Neptune Lander. My memory's pretty bad. So what we're going to do is we're going to create a sprite, just a bog standard sprite. Whoops. Oh, I am absolutely rubbish at graphics, but that'll do. Right, so let's save that. And I can't remember, did I import it? Yeah, so we'll do 5. So we'll load it into the 5th one. So this is the example we used, like I say, in tutorial 10, episode 10 of messing around. This is episode 11, yeah. Right, so it's definitely on the raster. Okay. Because the thing is, I was reading it because you remember Neptune Lander wasn't raster driven to start with. On Neptune Lander original, it wasn't raster driven. It was just a game loop, yeah. So I could be reading it more than one times a frame, and that's what threw me, yeah, because it was 0. So it could be, but we'll find out, yeah. So we need to make some more registers. So we are going to do sprite on sprite, which is equal to Vic plus 1e, and we'll do the sprite on background equals Vic plus, and I think that's 1f. Oh, it's not background, it's foreground. Foreground, and it's 1f. Only you would think of that. Only you would think of that. Hey Stacy. Right, so we need to create another sprite. So what we're going to do is we'll create another sprite. This one's going to be sprite 1, and this is going to be 02 and 03. And we'll do the same with the pointers. So pointer color is 28, I think, and 9. Right, so we'll switch both sprites on. So we will change that from 1, 2, 3, 4, 5, 6, 7, 1 to do that. So we're going to turn the sprite on, and then we'll set the we'll fix sprite 1. We'll fix sprite 1. So we're going to fix it at 155. That'll be roughly in the centre of the screen, I think. We will set the sprite pointer of it, and it's going to be 192345 and we'll set the colour to be white. Be boring white, so that's 1. Right, let's see if we've got it on the screen. F5. I've got to remember it's F5 in here. So clearly I've missed something. And that's because I forgot to change this, wasn't it? There we go, F5. There we go. That's nowhere near the centre of the screen. So that's the sprite we're going to try and interact with. Now to visualize the register, I'm going to write a little piece of code. Yeah, I forgot about the borders, yeah. So I'm going to write a little bit of code. So what am I going to do? Oh yeah, so we're going to print binary. So what we're going to do is we're going to take the accumulator and we're going to represent it as a binary string on the screen. So we are LDY #0 so I want to, in fact, we'll do that. So I want to, LSR, do that, and add 30, store it, DEY, and we'll put screen locale there, DEY, branch if plus, back to looper 1, RTS. So that is going to put our a value from the accumulator on the screen, and I'll represent this by doing something like this. So LDA $$01101100, right? And then we'll do JSR print binary no colon. Not in this system. This is CBM. Oh yeah, okay. well spotted, mate. Well spotted. Well spotted. Right. So we've got that there because we're going to set it, yeah. So let's set LDA #04, store it in screen locale. That's basically so we can reuse this routine again and again and again. Right, so if right, F5. So here we go. Oh, and I bust it. What have I broke? What have I done wrong? LSR, LDY, DEY, branch to there, then return. I did say JSR, didn't I? Yeah. Oh. Oh, that's right. Oh, no. John, you are not in kick. Why add 30? Because 0 is 30, isn't it? Yeah, so if I want to make it 10101, then you add 30 because we're putting the bit into the carry, yeah? Oh, pressed F6. No. F5. Oh. Have I added 30, not $30? Oh. That should work. What? 1 is 31. Oh, I know what. Ah. Rats. Right, LSR temp, add 30. So we're gonna have to LDA 0. You're messing around with my thingy again. Right, that should do it. F6. There we go. There we go. Sorted. Right. So this now is for us to be able to represent a byte. Yeah, because I want to be able to show you what's going on. So we are going to so that works now, so I'm happy with that, so I can get rid of that.
Boy, John, pay attention to chat.
What for? Hang on. Hang on. Yeah, okay, I'll let you off, mate. I didn't see it. There you go. What do you mean? Pfft? I didn't see it, mate. I didn't see it. I only saw the why did you add 30. I didn't see the next one later. It's a bit tight. Right. Okay. So we're going to carry on. So we'll create another one. So this is sprite to sprite collision, and we're going to give it a memory address 02AE, and we'll do, while we're here, sprite to foreground collision 02AF. Bar humbug. So what we're going to do is we're going to loop round. We're going to loop round this, and we're going to be putting the characters on the screen. We're going to put the result of the collision on the screen. So where we do there, I think it's there. Yeah, there. That's changing it. So we're going to do it in there. Right. So what we're going to do is going to go hello. Hey neighbours, there is a sprite to sprite. Right. I'm ignoring you guys. Right. So we are looking for that. So we're going to load the register that returns whether one sprite has hit another. Yeah. And what we're going to do, we're going to represent that at the top of the screen. So here we go. So we've loaded the register, and then we're going to send it straight to the print routine, basically just to see what it does. Right. Oh, and currently it's not printing anything. Oh, that's because I'm not actually going to, am I? There we go. Right. Now it's slowed it down because it's doing the printing of the byte. But as you can see, the sprite is just wandering around and we've got 0. So what happens now is we should end up... Okay. What do you mean no? What do you think's going to happen if I cross the streams, cross the sprites? Well, let's see, shall we? Nothing. and that is... This is what threw me. This is what threw me in... set the bit? What bit? Thought you didn't need to set the bit. I thought that was to do with the IRQ. I thought that was to do with the IRQ. Enable IRQ when sprite collides with a sprite. I don't want to do that. Oh, here we go. Right, got you. Let's add that then. Is the collision between two sprites a possible source of an IRQ? No. Is the collision between... That's the IRQ register. Oh, control register. Here we go. Is this it? No, that's not it. Yeah, I'm trying to find it. Because I don't want to do... Right, I don't want to do the IRQ. And that's what I did in Neptune Lander, right? When I switched it on, it kept firing the IRQ, and I don't want to do that. So is it this one? It's not... It's not that, is it? Are you sure? Enable IRQ to occur.
Oi, John, pay attention to chat.
Yeah, I'm there. But that's the IRQ mask. That's to enable... Sprite, that's the register. That's the... No, 1F is the... That's for foreground. Alright, we'll set DL19 then. Okay. We'll set DL19. Let's see what damage we can do. Don't need that. Right, so... we are setting is a collision between the sprite and the normal background, so bit 1 and bit 2. So we'll turn them on, yeah? So it's bit 1 and bit 2. So it's these two. Here we go. Oh, I've pressed the wrong... Hang on, we got an error somewhere. Variable is already defined. Right then, let's try it. I thought that's the IRQ. So it's got, must be this one then. Enable IRQ. So 1A. So we're talking bits 1 and 2 again. This is what screwed me over in Neptune Lander. Oh, yeah. It's not that. That fires the IRQ and takes the system down. This. Oh yeah, hang on, yeah. try that. Oh, F6. I don't need the and. Alright then. No. Sprite on Sprite, which is 1E. Here, 1E. It's that one, DL1E. Okay. Now, the CPU's constantly firing an IRQ. It's not 1A. I fell into this trap on Neptune Lander. It's not 1A. That just turns on the IRQ. This was supposed to be so easy. Here we go. Well, bit 2 of the VIC IRQ register is set to 1. Any two sprites overlap, and bit 1 is set to 1 when the sprite shape is touching the that's the foreground. All right. Right, okay, so the sprite collision register would show that all three involved. Okay. While bit 2. After we've moved it. Admittedly, we're probably reading it in the middle of a frame. So let's read it before. The problem is okay. Right. I'm just wondering if because we're reading it and it's always 0. So if it's 0, it'll bypass it. Let's try it now. So it'll only come up when it registers there's been a change. There we go. There we go. It's because I was constantly reading it. And 99.99% of the time it's 0. 1,000 AMAK points. Well, that's for Andy telling me where to look. And that's for you putting it the thing in the right the idea. So as you can see, so if I move away, whoops, I mean it won't go to 0 because we're testing for 0, yeah? But what we can do is I have a missing, you have missing zeros. 1, 2, 3, 4, 5, 6, 7, 8. No, I haven't. Two, 4, 6, 8. Oh, to your AMK points. Right, so we are not printing out when it's 0. So what I ought to do is I wonder if it'll do it now. Let's have a look. I bet it. Oh, pressed F6 again. I think I'm reading it too quick. Yeah, I'm reading it too quick. Let's put... Did I have the... Yes. Right, let's put the raster back in. So now it's going to... Oh, this is going to be really slow. Where's the increment going? Right, let's move that increment up because that's going to be really slow now. So now we're just going to be moved once every frame, yeah? Oh, and I pressed F6. Oh, even doing that is slow. There we go. So we're detecting we're colliding, and then when it finishes, which that is still colliding, should go to 0, which it has done. There you go. Now that is saying Sprite 1 and Sprite 2 are colliding, which is true. But just to throw the spanner, what we're going to do is we're going to make it not Sprite 2, we're going to make it Sprite 3, yeah? I'm going to make it Sprite 3 just to show, and we'll increase that increment, make it a bit quicker. Right, here we go. So it's 0. So now it's sprite 1 and 3. There you go. So the way to use this, in Perfect 101, yeah. Now the way to use this is you would say, okay, my main character is sprite 0, yeah. So to detect a collision, you would load this. Now we'll store it just for the sake of it, and then we would say, so sprite 0 wants to go that way. LSR, yeah. LSR branch if carry clear to bypass. So basically, it would be saying, let's no, let's we'll still do that, but what we're going to do is we're going to load it back in branch if, and we are going to do this. Get rid of that. So we're going to load 1. Bypass is going to load 0. Then we will store this in do20. So if your main character sprite 0, you can simply detect whether if every other sprite on the screen is a bad guy, you can easily detect whether your sprite has been touched by another sprite, because your sprite bit will always be set. No matter who else has touched you, your sprite will always be set. So it can be a very simple LSR. So you pass the bit into the carry and then test the carry. If the carry is blank, then we're not under attack. If it is, then it is. So what will happen now is the background should go white. So when we hit that other sprite, there you are, the background's black because we're not hitting the sprite. So we're still alright, look, still alright, not hit anything until boom. Simple, a simple test. And that allows you to do a quick test. If every other sprite on the screen is a bad guy, then you can quickly test that your character has hit a sprite by just testing bit 0 of the collision detection byte, by just LSRing it and then branch if carry clear. Now if you've got a system like Hunchback where sprites have different functions, yeah, then you have to test the other bits to find out which sprite has collided with you, yeah. But if the sprites, if there's another sprite, I mean, let's put another sprite on here. Let's put another sprite on here. Hi, I'm being raided. Hey, Hello Raiders, welcome to this tutorial. We are trying to decipher the collision detection system for sprites on the C64. Hello. Right, so let me so we'll put another sprite on the screen and we'll do that. And we'll make it, yeah, that should do it. Right, F6. Oh, I've done F6 again. F5. In lowish level mode. Stop bringing my bot into this. Stop bringing my bot into this. Yeah. Well, we are real low-level language. This is all about machine code, and we are. He's showing off. We are doing sprite detections. So, what I'm trying to show is that if we are those two are sprites 1 and 3, and as you can tell at the top, bits 0 and 2, which is equivalent to sprites 1 and 3, are on. But if we come to this sprite up here, bits 1 and bit 0 and 1, sprite 2. Now the problem is it gets complicated. This is dead easy if you've only got one good guy and the rest are bad guys, yeah. But let's say if we overlap these two sprites. So let's overlap them. And I've done F6 again. Right. So, straight away, look. Take the caps lock off. Really? Straight away. We've got two sprites colliding, which are these two here. But our background hasn't turned white. Have I got it on? Oh, take the keycap. Well, F6, yeah. Okay, I get you now. But as you can see, our detection system has detected two sprites of colliding, which is sprite 2 and 3. But they're not colliding with us. You know, sprite 1, us here. Yeah, because our background hasn't turned white. So you've got to be careful when you're doing sprite detection, because it will detect the other sprites that are colliding with everybody else. The important one that you're interested in is this bit here, which is set to 0, and this will only go to 1 when I touch the sprites. Now, the downside of this is the C64 doesn't tell you which sprite you're colliding with, because in this scenario there are 3 sprites colliding with each other, and so you can't tell, oh, am I colliding with sprite 2 or am I colliding with sprite 1? So if we let's say did that, yeah, we couldn't tell that we're colliding with sprite 2. That's sprite 2 in the center. Yeah, because the register says sprite 1, 2 and 3 are touching each other. Yeah, they're colliding with each other. But we can't tell from this which one is colliding with us. And that's where having a hybrid system that does both the hardware capabilities, which is what we're doing at the moment. We're using the hardware capabilities of the C64, and then you hybrid it with a software solution where you say, okay, right, I've collided with somebody, yeah, my collision bit is set, and we go and we have a white background, for example. Now, to work out who we've collided with, we then have to do the distance thing using the X and Y, where we I don't know. The problem is, how do we know which one to turn off? Yeah. How do we know which one to turn off? We try. Okay, we could try them all. Okay, we'll do that. We'll do that. So we need to because it'll only update on the next raster, yeah. It only updates on the next raster, so we're going to have to put a flag in here that says on the next raster, not to evaluate the keyboard and to run through. Will it update on disable? Don't know. Let's try it. Let's try it. So we are saying, let's say we're under attack, yeah. So here, let's turn off. Ooh, before John, before. Right. So we have got that for turning on, yeah. What have I got as the... that. And we're turning all three on. In fact, I'm just going to copy this. Here we go. Just going to copy that. Right, so we are going to get rid of that, make that into an LDA, and we'll turn off Sprite 2, yeah? And we'll see if it updates. So here we go, F5. Alright, so we've got the two sprites overlaid. Here we go. Okay, there you go. We still have three. We still have 3 ones. There we go. Now it did it on the next update, didn't it? It updated on the next update. Right. So we'll run that again just to make sure. F5. In fact, we'll do this one this time. Right, here we go. Wow. Well, that did go to 0, didn't it? Let's do that again. Here we go. It did. Well, it did then. Yeah, it is. It does. Oh, but hang on, we're reading it. We're reading it every time we're doing the raster. Right. Let's do this. Let's do this. We are going to read it twice. We are going to read it twice. So we're going to read it once, and then we're going to read it again once we have disabled it, and we'll put it on the line below. Yeah. So we're setting it for the line below. We're going to read it again, but I'm not going to save it. And we'll see if it changes when we disable it. Right. Here we go. F5. Nearly pressed F6. Right then, so we'll end up. Here we go. Boom. Now. It was just set to 0. It was just still set to 0. The only way we can, I suppose, the only way we can. Hang on, I ain't finished yet, mate. Hang on. I think the only way we could truly make sure is to do this. Is that we do the collision, we then wait for the next frame, then reread it and then print it out on underneath. Right. Oh, I've pressed F6. Right. So here we go. So we're going to hit. So what's going to happen now is we're going to detect that we have collided with something. We're going to turn the background white. We are then going to wait for the next. We are then disabling one of the sprites, and then we're waiting for the next raster. Then we'll carry on. Well, it did it. It updated on the next raster. So let's just prove it with that, doing it that way. Right. Oh, pressing the wrong key. Yeah, it does it, but you're right. The sprites would flicker, wouldn't it? Because we'd disable it on the next raster. So yeah, doing it that way is is fraught with danger. So the other way is to then test. I'm not going to say that, mate. Not going to say that. So what it means is that, you know, what you have to do then is you have to then go through the array, go through the sprite array to find out what sprite has interacted with you, so to speak. So the way to do that is, and this is what I did in Hunchback. So this is what I did in Hunchback. Alright. So let's get rid of these colons. Is that Nico? Nico? You've been naughty, eh? You've been naughty, eh? Eh? You've been naughty. All right. Then. Go on then. Go on. So, what you have to do is you run through your sprites, and at the moment this looks at an array of data. Yeah, it doesn't look at the sprites. So we have to tweak it. But what you do is you know your sprite 0, so you then look at sprite 1. What's the distance between me and sprite 1? So you subtract your y and you subtract your x, and if it's within a certain distance, then you say this is the sprite that's I've determined as within my sprite range. I'm just trying to think how I can convert it to what we've got. Because the x and y positions are in pairs. I'm going to do this. How are we going to do this? No, I've not created. This is just an example, mate. We're just talking directly to the sprites themselves. It's not like in Hunchback where we've got the array system, where we set the details in the array and then we use the sprite update routine to handle all that. Yeah, that's what I'm saying. I'm trying to think how I can make this. Yeah, in Hunchback it's all at one massive array. Hang on. So in Hunchback, there we go. So this is the sprite collision system for Hunchback. Yeah. Now we have got our sprite library, which was episode 4 of messing around with C64. So we've got this library here. This is the array lot here, all the way down to this. So all this lot from here all the way up to there. So we have the possibility of 18 sprites. Yeah. So we have to have an array that holds all our sprite information, because we are talking 18 sprites, not 18 logical sprites, 8 physical ones. And so all the data that's related to those 18 sprites are in these tables. So we've got the standard stuff. Is it enabled? What's the X and Y? What's the color? Is it multicolor? What animation frame? What priority? And if it's expanded or not. Then we've got the animation stuff. That looks after the animation of the sprite. And then we've got the linking of the sprites together and what sprites on screen and what's not on screen.
Here. Another subscriber. Stay a while. Stay forever.
Oh, Amok. Hello. Thank you for subscribing, mate. Much appreciated. And so the detection system. Where was the detection system again? Go away, you. Oh, I forgot where the detection system was. Let me search for it. There we go. Bad guys. Here we go. It's bad guys. Remember bad guys. So what I'm doing in the sprite detection system is I am looking. Here we go. So I'm looking in the hardware register. I'm ANDing it and I'm masking off Hunchback because Hunchback's two sprites. The high res sprite and the colour sprite. So I'm masking it out and then I'm leaving everything else on. And then what I'm doing is I'm running through all of these. Yeah, I'm running through all of these to see if any of those are within striking distance of me. Yeah, me, Hunchback. And I go backwards through it. And then what happens is then I then set I've got an array that says if I put a 1 in it, in that bad guy in collision array, that then tells me which bad guy I'm colliding with, because each bad guy has a different effect on Hunchback, because we've got one bad guy that doesn't kill him but just pushes him away. So when we fully implement this, that sprite will be pushing Hunchback back. We've got a sprite that chomps him, and and the other ones daze him, don't they, and stuff like that. So it allows us to be able to. It allows us then to interrogate the bad guy collision array to find out which guy, if any, has hit us, and if so, what type is it? Then work on it. But that's doing the mixture of the hardware detection. Have we actually done anything? Are we colliding with something? And if so, who is it? Who are we colliding with? Yeah. And basically, you just you subtract your number from the sprite number, and then you invert it. Yeah. If the number is greater than 15, then it wasn't that sprite. If it's less than 15, then you check the X register, and you do the same with that. So you load your place minus the sprite that's the offending sprite. If it's not negative, invert it, and if it's then greater than 17, that means there was no collision there. If it was less than 17, then you've satisfied both criteria. Then you can say, bruh, this guy's collided with us. And that's what's in this code. But I was trying to think how we could do it for just the array. Technically. We need another variable. That's what we need. We need right, okay, let's see if we can do this. We need another variable. X and Y for all. We only have 3 sprites. Yeah. The problem with that is, we can do it. It's just gonna take a little bit of clevery jiggery pokery. Yeah. So let's just. Oh, come on, John. I know my arm's hurting. Where did we go? Did I go up or down? Where's all that lot gone? Oh, no, my arm's hurting. B-O. Right. So let's grab that. So we're going to call this routine when we know we've hit someone, right? So I'm going to say store X into that, yeah? Then I'm going to load that. I'm going to times it by 2 and then transfer it into X. Now we can work it. So we're going to load Spry, X, yeah? So that is this. So we're loading the sprite that's affecting us with us, yeah? And we'll do the same with X as well while we're here. So we're loading the sprite that's potentially affecting us with us. Right, so I need to do... Am I losing X there? No, we're still keeping X alive. But here we're not. So we need to do this. We need to do that here. That's better? Right. Buddy, what's the matter? Do you want to go on stream again? You want to go on stream again? Hey? Oh, come here then. Come here. Say hello to everybody. Come on then. 1, 2, 3. There, stop it. Stop it. Say hello. Say hello. Hello. Yeah? You happy now? Alright? You happy? Go on then. Careful. Off you go. Right. I'm not picking you up again, mate. Right, so we should be able to figure out which sprite is knocking us about, because the end result will be X. Yeah, the end result will be X, and in fact we can test this anyway, because we still need to do this. And we still need to do that anyway. Load it in, de-exit, store it back, because it loops back to here. Then we load it, times it by 2, then we check with everything else. So we should be able to do this, right? So we're going to do that. Oh, I've done it again. So we're going to do that. So we have... Yeah, we're under attack. Captain, we're under attack. So we don't need to do that because we now know that is doing that. Oh, maybe so. So here, JSR. That. Now the end result should be X. Let's just have a quick look. Yeah, the end result is should be X, because it returns there, and that's the only time. So X is our result. So we should be able to do that, and then we will store X at 0410. And that should tell us, hopefully, which sprite we are colliding with. Hopefully. And we've got an error. Where have we got an error? Oh, there. Oh, that's gonna be tricky. Oh, that's gonna throw a spanner. We'll not we'll not worry about them yet. Oh, we'll not worry about those. That's going to take more thought. I'm trying to do it. I'm trying to show simply. So we're not going over the most significant bit realm. Right. So hopefully E. What's E? Screen codes. 5. Well, that's wrong. That should have been 3. Let's let's put a breakpoint on it. Let's run it through debugger. Oh, has it fired it up? Oh, I've got more than one going. Hang on. Yeah. Right. Let's put a breakpoint on the check, which is going to be there. No, that's our print, isn't it? It is there. Right, that's our place. Right, here we go. This was supposed to be a short stream. Right, here we go. Ready? Boom. There we are. We're in it now. So we're going to run through it. 7 times it by 2. Oh, that's divide by 2. Oh, wrong way round. Wrong way round. Times it by 2. Right, let's see if it does it right this time. So we should get... Hey, there we go. There we go. Right. So if I go round the other way, here we go. Oh, it said B all the time. Okay. That was just fortunate. Let's debug it. Let's find out what's going on. So we are looking here. let's do the other one. This runs okay on Hunchback. I'm just doing on-fly conversion, but it may not work without an array. Right, here we go. Boom. So we start with 7. Store it away, load it, times it by 2, transfer, load the Y. So that says 0, which is correct because it's switched off. So it's loading here. So that's switched off. Load that, branch if plus. It's not that. Right, load 7, decrease it, store it away, back round, load it, times by 2, check again. 0. Yep, that's not us as well. Check again. This time we're on 5. So we're now looking at this sprite here, which is not active, so it should just bypass it, which it does. Now we're on this sprite. It's not active, should bypass it. Now we're on this one. This is the one, and that's come out with 0. Why is not? I wonder if it's still looking here. Right, 2. This is 0, 1, 2. Right, now we're here. Now we're here. Times by 2. Load it. There we go, 78. Subtract me, which says it's FE, which is wrong. Oh, no, it's not. That's right. Multiply it. Sorry, not multiply it. Negate it. That's it. It's less than 15. Right. Test the Y. So 9B minus us 12. There we go. That's B. That's B. So that's what, right.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Hello. Thanks for following. Right, so now we know that that one's working. So, and it's going to do it again. Right, so now let's go to the other one. Right, let's just make sure. Right, here we go. Boom. There we go. Hit. Right, 7. We know it's not going to do it on 7. So, let's put a breakpoint there so we can quickly go through this. Right, 7, 6, 5, 4. Here we go. So this is 2. So that says yes. This one, this is the interesting one. Oh, 17. Compare it with 17. Oh. Now I know why it's gone wrong. This. That's why. Right, now this should be right now. F5. I was just about to press F6 then. So it should now be able to tell us which sprite we're hitting. It's simply where I say, look, what are you on about? I got the jumper on as well, look. Look. A drunken reindeer. Bad jumper day as well. Bad Santa. Right. So, let's just check that this is working. So, here we go. This should trigger as B, which it does. Desubscribe. And this should give us... Oh, it did it. There you go. A. There you go. A. There you go. It's because the sprites are too close together. Hang on. Let's just separate them a little bit further. So where are we? We are 120. 150. Let's make that 140. No. 145. There we go. So we've still got the two sprites overlapping. We should, I think they're still overlapping. Yeah, they are. Right. So the hardware system is still, the C64 is still telling us two sprites are touching each other, but it's not us. So here we go. As soon as our bit, so remember, as soon as our bit goes active, right, as soon as our bit goes active, there we go, that's sprite A. So that's right, sprite 1. Where's sprite 0? Sprite 1. So now that's told us we're in contact with sprite 1, look, yeah? Right, and as soon as we cross over, look, we've just crossed over into sprite B. It's now telling us sprite B, sprite 2 is the one that's hitting us. Then it goes to A. So it'll all, because we're descending through the sprites, the topmost sprite will be the one that's always hit us. What? What's wrong? No, this is CBM Prog Studio. This is the one I'm helping code. I'm helping Arthur. I wrote the Git engine. Yeah. This is Arthur's project. Yeah? Arthur Jordiston. Yeah? But there's me, I'm on it. But I help code. So I wrote the Git engine and Arthur put it in. But Arthur does majority of the work. And also, I wrote the kick error capture system as well. Right, anyway. So, hardware sprite detection. So we've just shown that we can detect our sprite. So our sprite is interacting with this one. So the C64 is telling us that our sprite, which is this one, has hit something. We don't know what. It's hit something. Then we use the software side of it to derive which sprite we hit. And the way it works, it goes down through the sprites. So sprite 0 is always, oh. Correct me if I'm wrong, Andy, but is sprite 0 the backmost sprite or the foremost sprite? It's the foremost sprite, isn't it? So 765. I think it goes. So as you're looking at the screen, I think sprite 0 is always on top, isn't it? And then sprite 1 goes underneath it. And then sprite 2, which is right, because look, the white sprite is sprite 1, the cyan sprite is sprite 2, so it goes underneath it. So we're always on top, but the detection system is checking backwards. Yeah, so it's checking backwards. Now we can change it that it will always give us the topmost if we want to. It's just a case of changing the direction of the X. But you know, it's like there, right? Because we're in collision with sprite 1 as denoted by the A up here. But as soon as we get into there, right, it says we're in collision with sprite B, which we are. We're also in collision with sprite A, but it's got to pick one, yeah? Because what happens, that routine is just coming out and saying, this is the sprite that you're in collision with. Now the one in Hunchback evaluates all the sprites. It doesn't matter. It evaluates all the sprites. It doesn't jump out and say, oh, I've given you a sprite. It evaluates all the sprites and gives us an array of all the sprites that are in collision with us. But this system will always return back the bottommost sprite that's colliding, and that's why we're getting this sprite, even though we're sat on top of this one. Yeah. So that is sprite collisions. Now, foreground collisions. I mean, we've turned it on, haven't we? Yeah, we've turned it on. So foreground collisions is just the same. The only difference is we're reading a different register. Right? So we are going to turn that off. We are going to rem that and rem that. I'm going to rem that. So we're going to LDA not that. So this is the register we're going to read. So that's what we're going to read, and we're going to display the result, and then we're going to load what we've just stored. And then we're going to just change the background color whether we've hit the background or not. So here we go. So we should have a white background straight away. There we go. Our sprite is now touching the foreground, our sprite. So if I move the sprite out the way, here we go. As soon as we leave, gone. So that sprite is no longer touching the background. Touch the background, comes on. And that's exactly the same sort of system. But you're actually saying, is sprite 0 interacting with anything in the background? Or in the foreground, sorry. And the answer is, if it's a 1, it's yes. Now these two are not interacting with any of the foreground, and that's why they're zeros. But if these two were up here, in fact, let's put them up there. So 8, 16, 32. The background was pixel accurate when I did Neptune Lander. So what was it? 32, 92. Let's do 95. Let's see where they turn up. No, I need to be a lot lower than that. There we go. Right, so we have 3 sprites on the background. Yeah, all 3 sprites are on the background. Now, there's not enough space. So if I knock, right, I'm going to knock these down. I'm going to knock this down by 6 and that by 12. So that's going to be 77, 71. Oh, I pressed F6. Pressing F6. Oh dear. Right. Do we have... Oh, is it still touching? Yes, it is. Hang on. Now it shouldn't be. Right, there we go. So as you can see, we've got one sprite here touching the background, one sprite not touching the background, but it's still touching this sprite, and we are touching the background, and it's resulted in that this sprite, which is that one, and this sprite, which is that one, this sprite is 0. So it's the VIT, the C64 is telling us exactly what. Now pixel perfect, here we go, pixel perfect. Let's see what we can do. See if we can get that. Oh yes, it's pixel perfect, alright. In fact, I'm not quick enough. There we go. There we go. There. There we go. So we have just touched the full stop. In Hunchback, are you detecting which character you collide? You mean the map itself? Are you talking about the map itself, not the sprites, but the background, yeah? Yeah, we do. Because if I run it... If I run it, yeah? As soon as I walk into the fire... ooh, hang on. Here we go. As soon as I walk onto the fire, look, because the fire is not, he goes down. Oh, I've forgotten what jump is. Aha! There we go. Right, so let's jump. Ah. So we are detecting the character underneath us, yeah? Because when what's happening is that the sprite is just touching that character, right, which then sets the flag. So we then say, oh, we've touched the character, we move up one, so we're no longer touching it, and then we evaluate what's beneath us, yeah, we look at the characters beneath us. Remember, I think it was episode 6, I think it was episode 6 Hunchback, when we was doing all this, 5 or 6, it was round there. It's one of the first things we did. And so, and like on the ropes, you know, we're always the background collision flag is always on because it's a rope. But because we're evaluating the characters underneath us, that tells us, oh, this is a rope. Oh, the timer ran out. We ran out of oxygen. Better get a move on. Move. See, this is something. This is where we left it, because it's trying to figure out where these power pills were. Yeah. See the power pills. There's another one there. Yeah, it's detecting it. So we'll have to. Well, in the new year we'll be back on this, because we need to do power pills and stuff. But we've got all the different. Oh, I forgot. I forgot they kill me. So yeah, so this is all this technology is in Hunchback. Yeah, we're just implementing it a different way, because Hunchback, we are talking logical sprites, because we have 18 logical sprites that fit in 8 physical sprites. So we're doing a bit of sprite management. I won't say multiplexing, but management. Yeah. And so and that's why when on the screens we never have more than 8 sprites on the screen. If we run this, if I run this in C64 Debugger. Oh, I've still got that running. So if I run this in C64 Debugger, alright, so all our sprites are up here, yeah? So, oh, Let's get off that one. Where's the other one? Ah, there we go. So here are all our sprites here. So at the moment we've got 3, which is this one, and this one. Right, let me see if I can... Oh, it's slow. It doesn't like C64 debugger, does not like my PC like this. So at the moment we're using 3 sprites, yeah? Whee! Now we're going to be yeah, again, Mac. Yeah, right. Go, run. There we go. So we go up. Whoa, whoa, whoa. Now you'll see some other sprites come on into the fore. Look. So now we're reusing the sprites depending on what sprites are on the screen. So there's the man. Then we should get, there's the arrow because he's come on. We should get a fireball in a minute. Are we going to get the fireball? There it is. So there we get to 1, 2, 3, 4, 5 sprites on the screen, even though that these sprites are being reused for other things. So let me see if I can. Let's see if I can jump over. No, I wasn't quick enough. But as you can see, there's another sprite there now on the... So that's 7 sprites we're using. I know what's wrong with this. I need to run it in admin mode. Hang on. Let's run it in admin mode. There we go. It runs a lot better in admin mode. Jump down, see if we can get to, jump over that, jump up. Right, got to jump over those spikes. There we go. So we're now on 7 sprites. Where's the other one? There's 2. Yeah, 7. So jump. Oh, I jumped too early. But Hunchback has a different system, right? Because we have 8. Yeah. Tell me about it, mate. But in Hunchback, we have 18 logical sprites. So 18 logical sprites to manage, but we can only represent, of those 18, 8 on the screen. And remember, Hunchback takes 2 because of the high-res one and the low-res one. So that has a different collision system, which I've tried to re-engineer back into using just the VIC registers to allow us to detect which sprite is and the data. So what was meant to be just an hour-long stream has now turned into 2. So that's Sprite Collisions in a nutshell. So I hope this has helped people understand how to use the hardware, sprites, and remember we have to set this, which is what got wrong in the next other place. There is also another setting which is 1A, which means that if there's a collision, it fires an IRQ, and then you can handle it using the IRQ system. It's only once a year, mate. It's only once a year. So we've learned how to set the register so we can read the collisions, then read the collision register, and then how to act on it. We've also learned how to evaluate the sprites to find out which sprite we've collided with, and also learned how to set whether the sprite has collided with the foreground or the text. So it allows you to do, or in my case it was Neptune Lander, that's where I first come across it, which was did the sprite interact with the background for when we crashed or landed. And so hopefully that's helped people understand how sprite collisions detect, the hardware sprite detection system in the C64 works, with the hybrid of code to allow us to determine which sprite has collided with us. So I hope that's been useful. I hope it's been entertaining. I try to be entertaining. The code will be on my GitHub in the Twitch streams section soon, and I hope you all have a very Merry Christmas, and I might stream in between, but it might be just me playing Halo or Minecraft, and have a stonking new year. Take care guys, and keep safe. Merry Christmas everybody. I'd like to thank all the Patreons that are contributing to my channel. Without you guys I wouldn't be able to do what I'm doing right now. Thank you very much.